So the most important thing about loading an electronic data file in Python is checking it to make sure it loaded correctly. There's a loop that you have to follow where you load the data, then you look at the data to see if there are any problems with it. And if you see problems, you go back and you reload the data, trying to correct those problems at the point it enters Python. So here, this is the Jupyter Notebook with examples for this week's module. Here, I've posted on my GitHub page a data set, a CSV file, called the American National Election Study. The American National Election Study is a massive survey conducted every 4 years right after the American presidential election. And they ask about all kinds of interesting things. They ask about who people voted for, but also what people feel about various political issues, about whether they've donated to any campaigns, about how they feel about different members of the political elites or groups in society. It's a really interesting data set, and it's one of the best snapshots of what the American electorate was thinking. So I encourage you to check this out if you have some time. This is a smaller and clean version of the ANES just for this example. So the first thing I do, you could see here, is I use the pandas read CSV function. And for read CSV, I can give it a file name with the full file path if it's stored on my computer. Or I can set the working directory and just call the file name. And there's an example of that earlier in this notebook. Or I can give it a URL if the data is stored online, as is the case here. This is the simplest possible function, pd, which is pandas, .read underscore CSV. Simplest possible circumstance for loading a CSV file. In this case, I just gave it the name and path of the function, and it worked. Okay, so next, I want to look at it. I want to make sure if it actually worked, or if I have to go back and make some changes. Well, the first thing I can do is set these display options. So I don't want to see the entire data frame. That takes up the entire screen. It really slows down your notebook. If I want to just get a sense of the structure of the data itself, I can do this. I can set option display max columns 10, display max rows 10. And then if I call the data frame, which I called ANES, then it gives me this, where there are only 10 columns displayed and 10 rows displayed. Now there are these dots in the middle that represent, I'm going from the first 5 to the back 5. There is a lot of data contained in these dots, okay? But this is a useful first pass at wrapping our heads around what the data look like. Now there are other things you should do to understand what's happening with your data right after loading it. One, you could use ANES.head. So the .head method that's applied to any data frame variable stored in Python, it will show the first several rows, 10 because I wrote 10 here. And then likewise, we've got .tail, the last 10. I think these are really useful for seeing if there is some sort of header that the data authors put at the top of the file, or some sort of footer at the bottom of the file, because you're always going to want to get rid of the header and the footer. Now we might want to look at the data type of each feature in the data. Float and int, those are two numeric classes. Float for decimals, int for numbers with no decimals. Here I display max rows none. I want to see all the rows of the following table. I don't want it to cut it off with any dots. And then I use the .dtypes attribute of the ANES data frame to actually display all of these. Okay, so a lot of int, a lot of float, and then a few objects here. Objects are currently used for strings, that is words, and for categorical variables. And so we can see all of the variable types here. After that, I set the number of rows to be displayed back to 10 by default. I could use the columns attribute to see all the feature names. And here we have, right? So for example, this is whether they voted in 2012. That would have been the previous cycle. Who they're going to vote for in 2016, what they think about all these different candidates, and so on. You can look at this. It's pretty interesting stuff. There's also aeneas.info. With verbose equal true, it displays also the data table or data type table that we had above. .info shows you the dimensions. So 1,200 entries, that is 1,200 rows, 168 columns. So that's pretty useful information. It also, at the bottom here, tells you how many features of each type there were in the data. So that's pretty cool. And then finally, there's the .describe method. So here, I'm only going to look at the FT Obama variable. I know I'm mixing up my words, features and variables. Please bear with me on that. The FT Obama feature or variable in the ANES data. FT Obama, it stands for feeling thermometer. People in this study were asked, on a scale from 0 to 100, how warmly do you feel to Barack Obama? It's a way for people to express not just do you approve of Obama or not, but to what extent I approve of Obama. And so .describe displays these summary statistics. So you can see count, this is a number of non-missing observations, non-missing data points for this feature. This is mean. So on a scale from 0 to 100, the average was 50, with a standard deviation of 54. So quite a lot of variance here. It seems like people either tended to really like or really not like Barack Obama, which I think makes a lot of sense. This max, 998, is indicative to me of a problem because this is a 0 to 100 thing. So it turns out that they used 998 to represent a missing value. So the few people in the data who said, oh, I've never heard of Obama, they got a 998. I don't know who has never heard of Barack Obama, but they get a 998. That has to be changed, and that's one of the things we're going to have to go back and change, because the fact that there are 998s here, even if there are very few, it throws off the mean, right? Because these aren't coded as missing values, or coded as very large numeric values. It's throwing off all of these calculations. So we're going to have to go back and fix that. Describe has a way to change the percentiles. So instead of up here seeing the 25th, 50th, and 75th, we can see the 20th, 40th, 60th, 80th by writing these percentiles. The median, 50%, will always be displayed. And then finally, for the objects, if we say include object, for those variables that are strings or categorical, it gives us a different set of summary stats here. It tells us the count of non-missing, the number of unique individual values, and then the frequency of the most frequent unique value. So describe, info, dtypes, columns, these are all really cool things to run right after you load a data set to wrap your mind around what are the problems and do I need to go back and fix those and reload the data.